Good morning students. Thank you very much students for clicking on my video. I am your Nagini ma'am chemistry mentor. In today's section I am going to discuss about the how to find the products formed at the electrodes during electrolysis process. This topic is from electrochemistry students second PUC topic. Here in this section I am going to solving the previous year's questions students. Okay Nama. So first of all, how to find for example, in two cases I will discuss you students, in the case of molten state, in the case of aqueous state. Okay now, so what are the products are formed at the electrodes? Now I am going to discuss students. Clear this one? So first of all, in case 1, only I am discussing about the molten state, molten electrolytes. Okay na, molten NaCl I am taking students example, molten NaCl. So what are the products obtained at the electrodes? Molten NaCl. So NaCl is the electrolyte students. Now how it is dissociate students? NaCl, it is dissociates into, NaCl is dissociates into Na plus and Cl minus, correct? Now if I take NaCl students, here sodium is the cation and Cl minus ion is the anion, correct? So here this is the cation, this is cations, this is the, I am taking like this is the cation students, Na plus ion, okay, and this is the, and which one Nana? Chlorine. So chlorine is the anion. Are you following? So Cl minus ion is anion students. So cations moves towards the cathode during electrolysis process. Cations moves towards cathode, anions moves towards anode. Are you following? Anions moves towards anode. So at cathode, which reaction is taking place students? Reduction reaction is taking place. At anode, which reaction is taking place students? Oxidation reaction is taking place. Clear this one? Oxidation is taking place. Now see Nana, here Na plus ion, it undergoes reduction. Reduction is nothing but gain of electrons. What is reduction students? Gain of electrons. Gain of electrons. Okay, electrons. What is oxidation students? Loss of electrons. Okay, loss of electrons. Now see students, here Na plus by gain of one electron it becomes sodium. So that means sodium is deposited at the cathode students. Are you following? So at the cathode sodium is deposited. Are you following students? So sodium is deposited at the cathode. Okay Nama. And coming to the here at anode. So at anode, what is the at cathode, what is the product students? Sodium is deposited at anode. Now see, what is oxidation students? Oxidation is nothing but loss of electrons. So Cl minus by loss of electrons it becomes half Cl2 by loss of one electron. So that's why here which gas is liberated students? Chlorine is liberated, Cl2. So chlorine, understanding students, chlorine is liberated at anode. Are you following? Cl2 is liberated. It is liberated at anode. Clear this one? So at anode chlorine gas is liberated students. Here cathode sodium is liberated. Are you following? Now I am taking the another example students, molten NaBr. Now see the molten NaBr. Second example, this is example 1. Okay, example 1, example 2, molten NaBr. Now tell me students, which are at cathode which is liberated, and at anode what is the product, which gas is liberated students? So by seeing this compound, molten is nothing but what students? NaBr is in the liquid form. Are you following? It is in the liquid state. So that means here water is absent students. Just by heating the NaBr compound it is becoming melting. Are you following? That is nothing but molten NaBr. Okay Namma. So this molten state only will call it as fused state also. Are you following? It is also calling as fused state. Now see students, molten NaBr. Now NaBr is NaBr. Now NaBr, in this NaBr, what is the cation students? Na plus is the cation, Br minus is the anion. Now this Na plus ions moves towards the cathode during the electrolysis. Cations moves towards the cathode anions moves towards the anode, student. So at cathode, reduction reaction taking place. At anode, oxidation reaction taking place. Are you following? Oxidation. So reduction is nothing but, what is reduction, students? Reduction is nothing but gain of electrons. Are you following? So gain of electrons. What is oxidation? Loss of electrons. Are you clear? Loss of electrons, students. Okay, loss of electrons. Now here gain of electrons, so that means Na plus by gain of one electron, okay, it is converted into sodium. So that means here which one is liberated, students? Here sodium is liberated. Are you following? Sodium is liberated at the cathode. Liberated at the cathode. Here which one is liberated, students? Br minus kada. So Br minus means which gas is liberated? Bromine gas is liberated, Br2. Are you following, students? So which one is liberated? Here Cl minus means which one is liberated? Cl2. Br minus means Br2. Are you following? So here Br2 is liberated. Are you clear this one? So Br2 is liberated at the anode. Sodium is liberated at the cathode. Are you following? So these are the, in case of molten electrolyte, students, this is the, like this you have to find done in case of molten electrolytes. Now in case of aqueous electrolytes, how to determine, how to find the products, formed at the electrodes during electrolysis. Okay, now this is the case to, students. Already in the previous section I discussed this all the topics. In this section I want to discuss the previous year's questions. Okay, so for that sake I'm giving this one again. I'm repeating this topic, students, just not more, students, just simple. Okay, na? So how in case 1, case 2, how to take, that means in case of molten state, in case of aqueous state. Okay, na? So how to take the products, I will discuss, students. See here case 2. In case 2, what is case 2, students? Aqueous electrolytes. So in case of aqueous electrolyte, students, aqueous is nothing but water. Are you following? Aqueous is nothing but water. So in the case of molten state, here only sodium chloride, only these electrolytes, cations only, cation and anions are there. But in the case of aqueous state, students, here H plus ion and OH minus ions also will be there, students. Are you clear? H plus and OH minus ions also will be there. So that is aqueous electrolytes. Now see, students, here you have to remember the 2 points here, at cathode, at anode. So the products at cathode. So first one at cathode I am taking, at cathode. Okay, and another one is at anode. Now see, students, here how to take here oxidation potential. So first of all, at cathode which reaction is taking place? Reduction kada. So that's why here reduction potential of water, it is always greater than reduction potential of Na plus. That means first, second and fifth and 13th group elements. Are you following? And 13th group elements, students. First, second, 13th group elements reduction potentials always less than the reduction potential of water, students. Okay, now then which is having the more potential, reduction potential, so that compound only undergoes the reduction, students. Are you following? So that's why water is having the more reduction potential, so that's why it is undergoing reduction, students. So water undergoes reduction. Are you following? Water undergoes reduction. Clear this one? So when it is undergoes reduction, here which gas is liberated, students? Hydrogen gas is liberated at cathode. Are you following? So water at cathode, which gas is liberating, students? Hydrogen gas, H2 gas is liberated. Just you remember like this. Okay, H2 gas is liberated. Okay, now second case, students, this is the first point, and coming to the second point, if the reduction potential, see here, now I am taking here first, second, 13th group elements. What are first group? Na plus. We can take example, students. First year group Na plus, K plus. Second year group Mg plus 2, Ca plus 2, and 13th group Al plus 3. So these ions we can take, Nana. Okay. Now reduction potential of water, if you take other than this one metal ions, okay, then the reduction potential of water is always less than those ions, students. Which ions? So Cu plus 2, okay, Cu plus 2, Ag plus Au plus 3, and Zn plus 2. Clear this one. And also we can say that Au plus 3 over Nama Cd cadmium plus 2. So these ions, if you take, these reduction potentials are more, students, than water. Okay now. So then which are having the more reduction potential? So these potentials, reduction potential is more, Nana. So that's why these ions are undergoing reduction. Okay now. So water does not undergoes reduction. Are you following? So which is having the more? Those are only undergoing reduction, students. So these are having the more reduction potential. So that's why these are the above ions undergoes reduction. Clear this one. These only undergoes reduction. So that's why here Ag plus. Now see, students, here Ag plus, what it can produce, students? Ag plus. Reduction is nothing but what, students? Gain of electrons. So by gain of electron, what will happen? By gaining of an electron, it becomes silver. So that means Ag can deposit Ag plus ion, it can produce Ag. Okay, so that means silver is deposited at the electrode, at the cathode. Like that only here Au plus 3. If I take Au plus 3, Au is deposited. If I take Zn plus 2, which one is deposited? Zinc. Cadmium, if I take, cadmium is deposited. Are you following? At the electrodes. Now I am taking at the anode. Now see, students, at anode we know that oxidation reaction is taking place. That means we have to take the oxidation potential. They have the oxidation potential. So first point, oxidation potential of water is greater than which ions, students? Here F minus. Okay na, F minus SO3. Okay na, sulfate ion SO3. So this is sulfite ion, and sulfate ion SO4 minus 2, and nitrate ion NO3 minus, thiosulfate S2O3 minus 2. Clear this one. So these ions. Now if you see that these ions, students, these ions oxidation potential is always smaller than the water oxidation potential, students. So that's why water is having the more oxidation potential. So that's why water undergoes oxidation. Are you understanding? Water undergoes oxidation. So whenever water undergoes oxidation, okay now, which gas is liberated, students? O2 gas is liberated. Okay now, O2 gas is liberated, students. Liberated at anode. Okay now, so at anode which gas is liberated? O2 gas is liberated. Are you following? Water at the cathode, which gas is liberating, students? If it is undergoing reduction, hydrogen gas is liberating, students. You just remember. Okay now, water. Okay now, water, if you take aqueous is there, means water. Okay, at cathode, anode. See here. Now I am taking water at cathode and at anode. Which gases are releasing, students? Just you remember this one. At cathode, hydrogen gas is liberated. At anode, O2 gas is liberating. Are you following? So just you remember this one, students. At cathode, water. If suppose at cathode, water undergoing reduction produces hydrogen gas. If water undergoing oxidation at anode, it liberates O2 gas. Clear this one. So here O2 gas is liberated, students. Now I am discussing the second point, students. See here, what is the second point? Oxidation potential of water is less than other than this ion, students. So that means we can take Cl minus, Br minus, and I minus. Okay na? So these ions. Now these ions oxidation potential is more, students. Okay na? Potential is more than water. Clear? So that's why these ions are undergoing oxidation. Are you following? So here which ions are undergoing? Cl minus, Br minus, I minus undergoes oxidation. Clear this one. They undergoes oxidation. Cl minus. Now Cl minus liberates which one, students? Cl minus ion liberates which one? Chlorine gas. Br minus liberates Br2 gas, and I minus liberates which one, students? I2. Are you following? So these are liberating at the anode, students. Okay, just you remember this trick, students. Then we are going to discuss the previous year's question, students. See here, what is the first question? See here, name the products liberated at anode and cathode respectively when an aqueous solution of NaCl is electrolytes. Aqueous solution given. So first, what is there? What given? That right, student. Solution. Aqueous solution given. Aqueous solution of NaCl given, correct? NaCl. So take NaCl. Okay, it is first of all, aqueous is nothing but what, students? Water also will be there, correct? So it is dissociates into Na plus and Cl minus ion, and as at the same time these ions, Na plus ion, Na plus N, because aqueous is nothing but water. So that means Na plus water, both you have to take Cl minus water. Now these ions, these are the cations, Na plus, these are moving towards cathode. Okay, now these are moving towards anode. Are you following? This is anions, these are moving towards the anode, students. Okay, now see, students, at the cathode, which reaction is taking place, students? At cathode, reduction reaction is taking place. Reduction taking place. Now in reduction, which potential will be there, students? Reduction potential. Okay, na? So reduction potential will be there. So what is here? Reduction potential you have to check. Reduction potential. Okay, at anode, anode is undergoing which one, students? Oxidation. So oxidation means which potential? Oxidation potential you have to see. Are you clear this one? Oxidation potential. Now see, students, reduction potential of water and Na plus. Which one is more, students? Na plus or water? So water is more, correct or not? Water reduction potential is more than Na plus ion, because here I discussed you water reduction potential is greater than which one, students? Na plus ions, that is first year group elements kada. So that's why water undergoes reduction, it produces H2 gas. Are you following? So that's why here which one is undergoing reduction, students? Water undergoes reduction. Clear this one? Water undergoes reduction, students. Okay, now because water reduction potential is more. Are you clear this one? So water, here what I told you, water reduction potential is greater than Na plus reduction potential. Okay, so that's a water undergoing reduction. So that's why here water at reduction, which gas is liberating, students? Hydrogen gas is liberating. Okay, now coming to here Cl minus and water. Now which potential is more, students? Oxidation potential. Cl minus water, Cl minus ion oxidation potential is more than water, students, correct, Amma? So here backside already discussed you. Cl minus ion, this potential is greater than water oxidation potential, correct? So Cl minus potential is greater than water potential. So that's why here Cl minus ion undergoes, okay, here you just write Cl minus ion oxidation potential is greater than oxidation potential of water. Okay, Nama? Water. So that's why here chlorine undergoes, here which one undergoes oxidation? Cl minus undergoes oxidation. So that's why it liberates which gas? Cl2 gas. This is the answer. So at cathode, hydrogen gas, at anode, Cl2 gas, H2 gas, Cl2 gas. Now see the options, students. H2 Cl2 is the correct answer. So this is the correct option. Now coming to the second question, students. What is the second question? During the electrolysis of aqueous solution of, see, students, during the electrolysis of aqueous solution of copper sulfate having the platinum electrodes, the reaction taking place at anode electrode. So here they are asking the question, at the anode what is the reaction is taking place? Is asking students what is the reaction. Here what given, students? Aqueous solution of copper sulfate given. So take that one solution, aqueous copper sulfate solution given, aqueous copper sulfate given, so it is dissociates into Cu plus 2 and SO4 minus 2, correct? It is dissociates into, first of all, Cu copper sulfate, it is dissociates into Cu plus 2 plus SO4 minus 2. Clear this one, SO4 minus 2, students. Now Cu plus 2 ions are moving towards the cathode. Are you following? So first of all, I am taking at cathode and another one is at anode. Now you see, Nana, at cathode which ions will come? Cu plus 2, and at anode sulfate ions, SO4 minus 2. At cathode copper ion plus water, both will be there. Here also water, because aqueous kada, so that's why you have to take both. Now which one? At cathode we know that reduction potential will be there. So which reduction potential is more, water or Cu plus 2? Cu plus 2 Cu plus 2 reduction potential is more. So that's here which one is liberated, students? Copper is liberated. Are you following? So here copper is liberated, students, at cathode. Okay, now but anode, then what is the reaction taking place at anode, they're asking. So SO4 minus 2 water. Now which is having the more oxidation potential, students, here in water and sulfate? SO4, which one is having more? Water is having the more oxidation potential, correct? It is having the water is having the more oxidation potential, students. So that's why water undergoes oxidation. Are you following? It undergoes oxidation at anode and it produces which one, students? O2 gas is liberating. It is liberating O2 gas. So water undergoing oxidation means it lost electrons. Now which option is correct? See, students, here water undergoing, water here there. Now see, at anode is asking reaction. So water undergoing oxidation potential is more, so O2 gas is released. Now in these reactions, in these two reactions, water reactions, here oxidation is nothing but loss of electrons. At the same time it is liberating O2 gas. Okay, now so that's why option C is the correct answer. Are you following, students? This is the correct answer. Okay, clear, Nana? At anode which reaction is taking place? To water, it is lost electrons and liberates O2 gas. Clear? So that is the correct answer. Now coming to the last question, see, students, here on electrolysis of a solution of dilute sulfuric acid between the platinum electrodes, the gas evolved at the anode is. Which gas is evolved at anode is asking question. But here what given? Dilute sulfuric acid. Now solution, dilute sulfuric acid take. Okay, dilute sulfuric acid, it is dissociates into 2H plus SO4 minus 2, correct? SO4 minus 2 nano. Now here cations. Now these cations are, this is dilute is nothing but what, students? Dilute is nothing but aqueous solution only. Okay, now these H plus ions at cathode and anode you take here. At cathode, at anode. At cathode, which one will be there? Cations are moving towards cathode. So that's why H plus ion, water. And here anode, which ions? SO4 minus 2 and aqueous. So that's why water I am taking. Now at anode only asking question. So at anode, which gas is? Now here at anode, oxidation reaction taking place. Oxidation potential you have to see. Oxidation potential of sulfate ion and water. Which one is more? Sulfate ion, sulfate to water kada. So water oxidation potential is more, correct or not? Because here I discussed you in the trick only, which one is more? Oxidation potential of water is more than sulfate ion, correct? So that's why here water oxidation potential is more, so that's why water oxidation potential is more. So that's why water undergoes oxidation, students. It liberates which gas? O2 gas is liberating, O2 gas at anode. So answer is which option, students? O2. So option C is the correct answer. Clear this one? O2 gas is liberated, students. Okay, Namma? Okay, students, I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, students. Thank you very much, students.